Working safely on electrical equipment requires knowledge, the right safety equipment, established procedures, and the proper attitude to ensure individual and equipment safety. This videotape will describe some of the hazards associated with electrical equipment, demonstrate ways to minimize exposure, and how to avoid these hazards. It will also examine safety equipment, discuss communications on the job, including the importance of a formal lockout and tag procedure. And finally, it will discuss standard safety routines which should be followed when working on metal enclosed switchgear, outdoor power circuit breakers, transformers, and capacitors. But knowing about safety is not enough. You must be committed to safety. Every day, on every job, you must think safety, because the equipment you are dealing with is terribly unforgiving of mistakes. To demonstrate how real the danger is, let me tell you about two men who let their guard down for just a second. Electrical shock is one of the greatest dangers in working with electrical equipment. It occurs when all or part of your body becomes a conductor of electricity, and the danger increases as the current increases. You probably wouldn't notice a current of less than 1 milliamp. However, a surprise effect may be experienced up to approximately 4 milliamps. Between 4 to approximately 20 milliamps, you will have a reflex reaction, but you'll retain the ability to let go of the energized gear. The surprise of getting shocked, however, may cause you to fall or strike other equipment, causing serious injury. Between 20 and 40 milliamps, any muscle in the path of current will go into a state of uncontrolled contractions as long as the current is applied. Now that we have looked at some of the ways electricity and electrical equipment can hurt you, let's look at some of the ways you can protect yourself. As we previously discussed, to protect yourself from electric shock, you must prevent your body from becoming a path for electric current. This is accomplished by de-energizing all equipment in the vicinity, or, if this is not possible, insulating yourself and your tools from all sources of electrical energy. To demonstrate these safety procedures, we will follow our technical service person as he works on typical electrical equipment. Dave has planned ahead and arrives at the job site with the proper tools and equipment. Standard equipment includes a toolbox, voltage detector, circuit breaker padlock, hard hat, protective shoes, safety eyewear, warning tags, and rubber blankets and gloves. For certain jobs, he also brings along rubber insulated sleeves. When performing service on power equipment, the installed grounding switches or ground and test device should be used. If none are available, Dave brings portable grounding cables and a hot stick with him. And above all, plan ahead. Dave always learns as much as possible about each job before he starts. He familiarizes himself with the power system by checking the system one-line diagram for all potential sources of current, including secondary sources such as backfeed voltages through potential transformers, control power transformers, current transformers, and emergency power sources such as emergency generators. Dave also secures the area using ropes, warning tape, and danger signs to keep traffic to a minimum. In addition to keeping unauthorized personnel out of the area, it reduces the possibility of bumping into something he is trying to avoid. Dave and the plant engineer decide together which fuses and potential transformers should be opened to eliminate as many potential sources of power from the work area as possible. Next, they review which breakers and switches should be opened. Once opened, the plant engineer locks out the device and places a warning tag through the mechanism to prevent unauthorized use of the equipment. As an added safety measure, Dave also locks out the equipment using his own padlock and tag.